Hello and welcome. I am Gianluca Marato and this is a new video on practical statistics. When you look at a dataset, it's not enough to know just the average. Statisticians often need to know how values are spread and how one specific value compares to all the others. To do this, we divide the data into meaningful parts. In this lesson, we'll focus on three key tools: quartiles, deciles, and percentiles. You'll see how each of them slices your ordered data into equal sections, 4 parts, 10 parts, or 100 parts. By the end of this video, you'll know what quartiles, deciles, and percentiles are, how to calculate the positions that define them, and how to interpret statements like "you're in the 90th percentile" in real situations. These concepts are fundamental in statistics, data science, and analytics. They are used in exams, finance, health indicators, dashboards, and many other applications. Let's get started. Before we get into quartiles, deciles, and percentiles, we need to answer a basic question: why divide a dataset at all? Imagine the chart you see on the screen as any real dataset: exam scores, incomes, or response times. If we only looked at the average, we'd miss almost everything about how these values are truly behaving. By splitting the data into parts, we can understand the distribution. Are most values bunched together, or are they spread out across the range? We can also compare individuals. Where does a single person or a single observation sit relative to all the others along this axis? And finally, we can detect extremes, those unusually low or high points at the edges that might signal outliers, risks, or exceptional performances. Dividing a dataset transforms a simple list of numbers into a structured picture. This is exactly what quartiles, deciles, and percentiles do. They turn raw data into clear, interpretable segments across the whole distribution. All three concepts we are studying, quartiles, deciles, and percentiles, are position-based. They don't just care about the values themselves, but about where each value sits in an order list. That's why step 1 is always the same: sort your data from the smallest value to the largest. In the example on screen, the unsorted list 8, 3, 10, 5, 2 becomes the ordered list 2, 3, 5, 8, 10. Only after sorting can we meaningfully talk about positions: the bottom 25% of the data, the top 10%, or someone being in the 90th percentile. If the data are not ordered, a phrase like bottom 25% is ambiguous, because we don't know which values are truly at the bottom or at the top. So remember this rule: all position-based measures, including quartiles, deciles, and percentiles, require ordered data. Sorting is the essential first step before any further calculation or interpretation. Let's now focus on quartiles. As the name suggests, quartile refers to 4. Quartiles take your ordered data and split it into 4 equal parts along the range of values. On the screen, you see a long bar divided into 4 equal segments. The first cut point is Q1, the first quartile. This is the value below which 25% of the data lie, the boundary of the lower quarter of your dataset. The second cut point is Q2, also called the median. It is the central value that splits the data into 2 equal halves, 50% below and 50% above. The third cut point is Q3, the third quartile. This is the value below which 75% of the data lie, marking the boundary between the middle part and the upper quarter. Together, Q1, Q2, and Q3 summarize the lower quarter, the middle half, and the upper quarter of your data. These 3 values are the basic ingredients of the box plot, one of the most widely used visual tools in statistics and data science. Here's a concrete example using test scores. On the horizontal line, you see the 8 ordered scores: 40, 50, 55, 60, 65, 70, 80, and 85. We use these positions to find the quartiles. First, the median or Q2. There are 8 values, so the middle lies halfway between the 4th and 5th scores. The 4th score is 60 and the 5th is 65, so the median is their average 62, 5. Next, Q1, we look at the lower half of the data, 40, 50, 55 and 60. The middle of these 4 values is halfway between 50 and 55, so Q1 is about 52, 5. Similarly, for Q3, we take the upper half, 65, 70, 80 and 85. The middle lies between 70 and 80, so Q3 is about 77.5. So in this class, half of the students have scores between about 52, 5 and 7, 7.5, and 25% are below about 52.5. Deciles take the same idea as quartiles and push it further. Decile means 10, so deciles divide your ordered dataset into 10 equal parts along its range. On the screen, you see a long bar split into 10 equal blocks. Each cut between blocks is a decile. The first decile, D1, is the value below which 10% of the observations lie. In other words, 1/10 of your data fall in that first segment on the left. In the middle, D5 marks the point where 50% of the data are below and 50% are above. D5 is exactly the median, just expressed in decile form. Closer to the right end, D9 is the value below which 90% of the data lie. Only the highest 10% of observations fall beyond this point. Data science give you a more detailed picture than quartiles, because they split the distribution into 10 slices instead of 4. They are widely used in economics, finance, and income distribution analysis, where understanding differences across many segments of the population is crucial. Percentiles go even further in dividing your data. Percent refers to 100, so percentiles split your ordered dataset into 100 equal parts along its range. Imagine the bar on screen running from 0% on the left to 100% on the right. Every point on this scale represents a percentile. The kth percentile, written as pk, is the value below which k% of the observations fall. So p10 is the value that has 10% of the data below it. p1025 is the 25th percentile, p1050 is the 50th percentile, and so on up to p1090 with 90% of data below that point. Now look at the highlighted markers. p-25 at 25% is the first quartile, q-1. p-50 at 50% is the median, also called q-2. p-75 at 75% is the third quartile, q-3. So quartiles are just special percentiles. Q1 is p-25, Q2 is p-50, and Q2-3 is p-75. Percentiles are used constantly in real life, in standardized tests, medical reports, dashboards, and business performance metrics. When you read a statement like, "You scored at the 90th percentile on a test," this is not just a nice sounding number. It has a precise meaning. Your score is higher than 90% of all test takers in that group. You are in the top 10% of the distribution. The same logic applies in many other contexts. On a children's growth chart, being at the 30th percentile for height means that child is taller than 30% of children of the same age, and shorter than the remaining 70%. Percentiles always answer the question, compared with everyone else, where do I stand? They don't focus on the raw value alone, but on your position within the entire order distribution. This relative position is what makes percentiles so powerful for interpretation. Quartiles, deciles, and percentiles are essential whenever you want to truly understand how a variable is distributed, not just what its average is. By splitting data into ordered segments, these measures show you how values are spread out, where most observations are concentrated, and how unequal a distribution might be. They let you compare individuals or groups on a fair relative scale, not just what is your score, but how do you rank compared with everyone else. They also make it much easier to spot outliers and extremes, unusually low or high values that may indicate risks, errors, or exceptional performance. You will encounter quartiles, deciles, and percentiles in descriptive statistics, data science dashboards, machine learning feature analysis, finance, education, health indicators, and many other applications. Mastering these concepts gives you a powerful lens on any dataset, helping you move from raw numbers to clear, interpretable insights. Let's quickly recap what you've learned. To divide any dataset into meaningful parts, the first step is always to sort the data from smallest to largest. Then we can apply our position-based measures. Quartiles split the ordered data into 4 equal parts, highlighting the lower quarter, the middle half, and the upper quarter. Deciles split the data into 10 equal parts, giving a more detailed view across the distribution. Percentiles split the data into 100 equal parts and tell you exactly where a value lies relative to all the others. If you want to turn these ideas into real skills with hands-on practice in Python, check out my book Statistics with Python, 100 Solve Exercises for Data Analysis. Inside, you'll find step-by-step exercises on probability, hypothesis testing, correlation, and many other statistical techniques, all implemented in Python, so you can practice directly on data. It's a structured way to move from theory to real intuition by actually working through problems. Thanks for watching, and see you in the next video.